Okay, let's do some math for fun. Today we're going to solve sin c equals I. Yes, we did a video on sin c equals 2 last year. If you haven't seen the video, be sure you guys go check that out. It was crazy, right? Because how can sin be equal to 2? Well, not in the real world, in the complex world, yes. Just like this right here, let's see how we can actually solve sin c being I. And after the video, you guys can let me know if you guys this more or if you guys like sin c equals 2. I think this is better though, so check this out. Anyway, we have to utilize the complex definition of sine. Of course, it's going to be e to the iz minus e to the negative iz all over 2i, and this is equal to I. And of course, to go from here to here, you guys can watch my other video for it as well. Now, let's multiply 2i on both sides. So this and that will be cancelled here. And then we just get e to the iz minus e to the negative iz equals I times I is -1, and that will be just -2. That's good. Now, from here, I will multiply everything by e to the positive iz so that I can get rid of the negative exponent, and you will see this times that we can write it as e to the iz and then square. This times that we just get -1 because the power will be just 0. And let me just write it down right here. And then this times that will be -2 e to the iz. That's on the right hand side though. Let me bring to the left. So I get plus 2 e to the iz like this. And it's equal to 0. Why do you want to do that? Because now notice this right here is actually a quadratic equation because of this to a second power, this to a first power, and then no variable right here. It's a quadratic equation in terms of e to the iz. So we can utilize the quadratic formula, and that will give us e to the iz like this equals, of course, we can just do a negative b, which is -2, plus minus square root of b squared, which is 2 squared, minus 4ac, which is 1 and -1, so I'll put on -4 times 1 times -1, or over 2 times 1, like that. Now let's do this in your head. 2 squared is 4, minus this is minus -4, so 4 minus -4, which is 8. Square root of 8 is 2 square root of 2. I have the 2 on the outside. This is a 2. This is also a 2, so we can cancel things out. In another word, right here I get e to the iz equals, I get -1 plus minus just square root of 2 right here because we cancel the 2's already. So this is good. Now, we have two situations. -1 plus square root of 2 or -1 minus square root of 2. I'm actually going to separate them because -1 plus square root of 2 is a positive value. I can just take the natural log like naturally on both sides. That's okay. So let me just write down this right here for you guys. E to the iz first gives us -1 plus square root of 2. And then on the other hand, we get negative version right here. So I'll write it down as well. E to the iz equals -1 minus square root of 2. As I said, we will just take the natural log naturally for this. So this is good. Cancel things out. I just get iz equals, this right here is just that. Nothing too special because the input is a positive number. And let's just finish this first. Okay, I have I times c. Technically, I should divide it by I on both sides, but I don't like to be on the bottom, so let's just do this way. Let's multiply by -i throughout this equation, so that I times I is -1 times another negative, we get positive. Therefore, I still get my positive z by itself like this. And then I just have to do this times that. I don't need to be on the bottom if I don't want to, right? So we get -i natural log of -1 plus square root of 2, like that, and we are done. And this is the first answer. Well, right here, we pretty much do the same thing, except for -1 minus square root of 2. I have to factor out negative first, because if you just do natural log on both sides, oh man, when you are dealing with natural log of a negative number, if you just put this down, people will be mad at us. So we cannot do that. We have to do more work to please people. So right here, factor out -1, and we get +1 plus square root of 2, like this. And we see that on the left-hand side, we still get the iz. And then natural log of a product is the same as the sum of the natural logs. So I'll write down natural log of -1 plus natural log of this guy, which is 1 plus square root of 2. Well, what is natural log of -1? Yes, it's iPi. We did it many times already, but I will do it again for you guys. Right here, what you do is, look at -1 on the complex plane, which is right here. This is -1. And you need to know two things. First, it's the distance from here, from the origin to here. The distance is 1, and then the angle from here to here. And the angle right here is just pi. So you can write -1 as 1 times e to the I pi, namely the polar form of -1 in the complex world. Cool, huh? And then if you just put this into here, this natural log and this e will cancel out, so you end up with I pi. And you might be wondering, how come I didn't go like this? It's okay right here, because this is just an answer. We are going to find all the answers later on. Anyway, we get Iz equals, as I said, this right here will just give us I pi, and then we have this. And now this is positive, so we know this is a legitimate logarithm. So this is good. And once again, I'm not going to divide everything by I. I don't like to be on the bottom, so I'll just save some time. Let's multiply everything by -I. This is going to give us positive z by itself, just like that. This times that is going to give us positive pi, because I times I is -1 times negative is that. And then, of course, you just multiply this and that, which is -I ln of 1 plus square root of 2, like this. Okay, so we found two answers. This is so cool, but this is not it. Why? Just like this right here, as I said, well, this is pi or -pi, or you can also look at this as 3 pi and so on, right? So we have to go back to this part right here if you would like. Let's see. Let's take a look right here. E to the IZ. To make sense of this, well, we have to use the Euler's formula, which is cosine of z, which is that input right here. And then we add I times sine z, like this. You can just think about the z is like the angle. Well, when you have cosine, you know we can just keep adding 2 pi or keep subtracting 2 pi. The value is still the same. So it's for the sine. So in fact, I can just put on plus 2. Depends if you want to do 2n pi or 2 pi n, up to you. 2 pi n, I guess. You can also subtract, so you have to denote pi is an integer. So you just write this down, 2 pi n, and you put down where n is an integer. So you should write this down so that people will know that you know some cool notations. So look at this right here, it's z, right? Technically, I should have put down z plus 2 pi n right here. That's how we can get all the solutions. And of course, I can just bring this to the other side and all that. So what we can do is, let's just finish this like that. So finally, I'll just put down all the answers. This is going to be z equals, that's the first one, -I times ln of -1 plus square root of 2. Well, I use n right here. Let me just, dedicate this to pi m, Dr. Pi M. Thanks for watching. Hopefully he doesn't see that. I don't know if he watches my video or not, I don't know. Anyway, I will just put down 2 pi m, okay, for pi m, right? Yeah, because technically I should put this, but it doesn't really matter. Anyway, and then right here, I will just keep it as how it is. I'm not going to put I'm not going to combine the pi and then 2 pi m. You can do that if you would like, but I'll just put this part right here as how it is. So the idea is that you can always just find an answer, right? In this kind of situations, in this kind of equations, just find an answer or maybe two answers like this. And then in the end, don't forget to add the multiples of 2 pi and things like that. So 2 pi m for Dr. Pi M. In this case, I have to denote m is an integer, right? Well, this is good. I haven't bugged the answer yet because, yes, sine z is equal to I here. This is equivalent to say, let's take the inverse sign on both sides. I can say z equals inverse sine of I. So if you really want, you can also denote it by, hey, I get a sine inverse of I right here for you guys. Yep, so just a little thing if you would like, and perhaps I'll just present this for you guys for the answer. Right, so this is it. Leave a comment down below and let me know if you guys like sine c equals to I more, or if you guys like sine c equals 2 more. So leave a comment down below if you guys have any other questions. Also, leave a comment down below. As always, that's it.